In industrial automation, efficient communication between controllers and input-output devices is paramount. This is where Profibus, a widely adopted industrial communication protocol, comes into play. Profibus, short for Process Field Bus, enables seamless data exchange between programmable logic controllers and distributed I/O modules. Remote I/O, on the other hand, refers to the concept of locating I/O modules at a distance from the PLC, closer to the field devices they interact with. This distributed architecture offers several advantages, including reduced wiring costs, improved flexibility, and enhanced diagnostics. Imagine a large factory floor with numerous sensors and actuators spread across a vast area. Instead of running individual cables from each device back to a central PLC, which can be costly and cumbersome, Profibus, with remote I/O, allows us to group these devices into manageable units called I/O modules. These modules are then strategically placed near the field devices, minimizing wiring distances and simplifying installation. Profibus acts as the communication backbone, enabling high-speed data transfer between the PLC and the remote I/O modules. By adopting a Profibus-based remote I/O system, we can achieve a more efficient and cost-effective automation solution. The modular nature of this approach also enhances flexibility, allowing for easy expansion or modification of the system as our needs evolve. Moreover, Profibus offers robust diagnostic capabilities, making it easier to identify and troubleshoot issues within the network. In the following sections, we'll delve into the practical aspects of connecting Profibus with remote I/O, providing a step-by-step guide to help you get started. Before we dive into the setup process, it's essential to gather all the necessary hardware and software components. First and foremost, we'll need a Profibus-compatible PLC. This will serve as the central controller for our automation system. Ensure that your chosen PLC model supports Profibus communication and has the necessary ports for connecting to the network. Next, we'll require one or more remote I/O modules that are compatible with our chosen Profibus network. These modules will house the input and output channels for connecting to our field devices. When selecting I/O modules, consider factors such as the number and type of I/O points required, the environmental conditions of the installation, and any specific functionalities needed for your application. To physically connect the PLC and remote I/O modules, we'll need Profibus cables and connectors. Profibus typically utilizes specialized cables with specific impedance and shielding characteristics to ensure reliable data transmission. The connectors used are typically of the DB9 or M12 type, depending on the specific hardware being used. Make sure to use high-quality cables and connectors to prevent signal degradation and ensure a robust connection. Lastly, we'll need the appropriate programming software for our PLC. This software will allow us to configure the Profibus network, assign addresses to the remote I/O modules, and program the logic for our automation application. The specific software required will vary depending on the PLC manufacturer and model. Once we have all these components ready, we can proceed with the connection process. Now that we have all our hardware and software in order, let's walk through the steps of connecting Profibus with remote I/O. Begin by powering down the PLC and all connected devices. This is a critical safety precaution to prevent any electrical mishaps during the connection process. With the power off, connect the Profibus cable to the designated port on your PLC. You will find a corresponding port on your remote I/O module. Connect the other end of the Profibus cable to this port, ensuring a secure connection. Once the physical connection is established, we can power on the PLC and proceed to the software configuration. Launch your PLC programming software and navigate to the Profibus configuration section. Here you will need to configure the Profibus network settings, including the baud rate, network address, and other relevant parameters. Consult your PLC and remote I/O module documentation for the specific settings required for your setup. Once the network settings are configured, the next step is to assign addresses to each remote I/O module on the network. Each module needs a unique address so the PLC can communicate with it individually. You can typically assign addresses automatically or manually within the programming software. With the Profibus network configured and addresses assigned, It's time to verify our connection and troubleshoot any potential issues. Most PLC programming software provides diagnostic tools to help with this process. One common method is to monitor the status of the Profibus network within the software. Look for indicators such as online or running to confirm that the network is functioning correctly. Another useful diagnostic feature is the ability to read and write data to and from the remote I/O modules. This allows you to verify that the PLC can communicate with the modules and that data is being transmitted correctly. Try writing a known value to an output channel on a module and then read it back to confirm that the value was received successfully. If you encounter any issues during the verification process, there are several troubleshooting steps you can take. First, double-check all the physical connections to ensure that the cables are securely plugged in and that there is no damage to the connectors. Next, review the network settings in the PLC programming software to confirm that they match the specifications of your Profibus devices. If the issue persists, consult the documentation for your PLC and remote I/O modules for specific troubleshooting guidance. The documentation often includes helpful tips, error codes, and solutions to common problems. Additionally, many manufacturers offer online resources such as forums, knowledge bases, and technical support to assist with troubleshooting.